Hello, in this tutorial I will be demonstrating how to perform a frame buckling analysis in SAP 2000. Suppose you have this partial frame given to us. Uh, these are the dimensions of the frame, and this is a cross section. It's rectangular with a thickness of 1.5 mm and width 50 mm. And you are asked what magnitude of loads P1, P2, P3 when acting independently at points Z2, Z3, Z4 respectively will make it buckle. And to do that I will be using SAP. So you open SAP. Once you have opened it, go to File, New Model. You select the units. In this case I will be choosing Newton millimeters. There are different ways in which you can proceed. In this case I will be using grids. So first I will make a rectangular grid corresponding to Z4, Z3, Z5 and the corresponding point here. So for that I will be needing two grid lines for the x-axis, two grid lines for the z-axis and only one grid line for the y-axis. The length of the x-axis grid line is 300 plus d, that is 400 mm. Similarly the length for the z-axis is 600 mm. So x-axis I will be needing two grid lines, y-axis only one, z-axis two, x-axis grid line length is 400. We need not be concerned about the y-axis, and z-axis grid line is 600. Click OK. So I will change my view. This is xz. So this point corresponds to z0. Now I need another grid point which corresponds to this. So let me call. Its x coordinate is minus 2d, that is minus 200. So to make another grid point, you right click edit grid data, click modify, and let me call it C. So I'm inputting it in X grid data, so its coordinate is minus 200, and just double click on three of these and click OK, and then click OK. So you can see another grid point has been created. Now you can make the beams and the columns from the frame element toolbar. Now we will be defining the section properties. So we will create a new property. The section is rectangular. It can be found in concrete, and we change its material properties to that of steel. Its thickness is 1.5 mm and its width is 50 mm, and we will call it beam column. Okay, so when this is done, I am going to assign my frame sections. I'll click OK. So now the defined frame sections have been assigned. Now I'm going to define the load patterns. So if you see, we three load patterns, one acting at Z2 at a distance d from this end, another acting at a distance of 2d, and another acting at a distance of 3d. To do that, you select your beam and go to assign, and then go to first we will uh, define those load patterns. So to do that, I will be defining them as live loads P1, P2 and P3. So we can delete this dead load pattern, we do not require it. Yes. Now I'll be defining the buckling cases. So you select buckling here, and corresponding to P1, let us say I need only first four mode shapes. I can click set default name, so it will be called buck1. Okay, to make it faster I can add a copy of it, but this time I need P2. I do not need P1, so I will delete it, and I will the name set its name as buck2. Similarly, this is for the third buckling load case. So now I am going to assign loads. So we will need point loads. So corresponding to P1, it should be at a distance of 100 mm. That 100 mm is uh, at, at a fractional distance of 100 by 600, right? So this total length is 300 plus 3d, which is 600 mm, and so this length is 1/6 of 600. So this is the end eye. So at a relative distance of 1/6, that is 0.1667, let us input a load of 1. It's in the downward direction, in the gravity direction, and I will explain later why I have chosen it as 1. Okay, similarly again selected assign frame point load. This time it's responding to P2 and it's a distance of 2d, which is 1/3. So this corresponds to 0.333. Similarly again selected assign, and this time it's 3d, which is exactly 1/2 of it, and this corresponds to P3. Okay. Once you are done, we are going to now assign the boundary conditions, and in this case all are fixed. And now I'm going to set the analysis options. We need only in the XZ plane analysis. Click OK and set load cases to run. In this we don't want to run the dead load model, and in fact also the live load. We only need to run these three buckling cases. So I'm going to first uh, make sure that all of them are not run, and I'm going to run three of them. So everything is okay, so I can now run it. It will ask me, so let me call it as partial frame 4. So let me show you the buckled shape. Go to display, show deformed shape. So it will ask you corresponding to which buckling case you need and which mode shape. So we had mentioned 4 mode cases. Let's look at for the buckling case 1 and corresponding to the first mode shape. So now you can see there is a factor here, 505.72658. This factor means that a load of P1 times 505.72658 has to be applied at this point to make it buckle in the first mode. So that is why I had chosen the load as 1 Newton in the downward direction. So we now know 505.72658 Newton of force is required to be applied at this point to make this partial frame buckle in the first mode. You can also look at its animation, and you can take a look at the second buckling mode as well as the third mode also. Okay, so again you can look at the other buckling, uh, the mode shifts corresponding to other buckling loads also. So this factor has again changed. So this is it. Suppose now I want to make this support as as pinned. For that I will first unlock it. I will select this joint and go to assign joints restraints and choose the pinned one. And similarly I am going to perform the analysis again. So you can see the buckling load has reduced, uh, and which is also obvious. You can check for the other two remaining buckling cases also. Now another thing, which suppose I want that this joint does not uh, translate in the lateral direction, that is its displacements in the x and the y directions are 0. For that thing can also be done. I just have to select this joint and go to assign joint restraints. So I do not want its translation to occur in the x direction and out of plane. So these two will be checked, whereas I can allow it to deform in the z direction. So you click OK. So restraint has been added, and similarly you can perform another analysis corresponding to that. So you can see there, I think there will be a slight change, not too much of change. And you can also look at the second mode shape, this joint has been restrained. Okay, so I hope this is sufficient.